Hello students, welcome to the class of the digital electronics. Today we will solve some few examples based on the conversion of a number system. In the previous lecture we had discussed the number system and the conversion of a number system, correct? So first example is 77.43 base 10, and we need to convert this into the base 6. Okay, this is a capital N, so we need to find this capital N. So to convert any radix number system, okay, from the decimal number system, this is what we have given. This is the decimal number system. Okay, so in the previous lecture that we have discussed the conversion first, that is a decimal number system to any other number system. So this is the first kind of the conversion. So this is a decimal number system. So conversion of a decimal number system to any number system. So just you pick the base of this number system, and here in this left hand side there are two parts. First is the integer part, and this right hand side part is a fractional part. So just you do the successive division, okay, by this 6 of integer part, and successive multiplication by this base to the fractional part. Okay, so that is 77. So integer part is 77. So let us do the successive division, correct? So uh, uh, yeah, so 6 1 ja 6 and 1 6 2 ja 12. Okay, the remainder is 5, and 6 2 ja 12, that remainder is 0. So this is 205. This is the conversion that is only for this integer part. And what about the fractional part? So let us do the fractional part also. So 0.43 multiplied by 6, that is the successive multiplication. Okay, this one is successive division. So now 6 3s are 18, 6 4s are 24, plus 1 25, so 2.5. Okay, so now this 2 just you put here as it is 2. Now again 0.58, this one. Okay, multiply by 6, so 48, and 30 plus 4, that is 34, 3.48. So again just you put here 3, this 3. Okay, and again just you do again one more time multiply by 6, 48, and 24 plus 4, that is at 28, so 2.8. So this 2 just you put here. Okay, so this is the final conversion of decimal number system to base 6. Now question number 2. First let me just take the one another paper. Yes. So now example number 2, 75, that is base x, is equal to 45 base y. Now find out the suitable value of x and y. Clear? So this left hand side, that is 75, that is given, but we don't know the base. Same as right hand side 45, that is given, but we don't know the base y. Okay, so let us convert this left hand side number system into the decimal number system. Clear? So decimal number system, what is the procedure to convert this left hand side into the decimal number system? Just multiply the particular bit by its weight. So what would be the weight of this x to the power 0? What would be the weight of this one, x to the power 1, and multiply by the corresponding weight. So x to the power 0 is 1, multiply by 5, 5, plus x to the power 1 is x into my 7, so 7x. Correct? So same you do in right hand side also part. So 5 y to the power 0, that is a weight, y to the power 1 to the weight of this bit 4. Okay, so that is 4 of y plus me 5. Clear? So what I did actually, left hand side, this convert this left hand side part into decimal, right hand side also that convert into the decimal. Correct? So now 7x minus 4y, that is equal to 0. So 7x minus 4y is equal to 0, or you can also do 7x is equal to 4y. So now just you check here from the question itself, x can be greater than or equal to 8, isn't it? Because the maximum number is 7, and y, that is base, that is greater than or equal to 5. Clear? So is there any possibility of x and y where x is greater than equal to 8 and y is greater than equal to 5, that satisfies this equation 7x is equal to 4y? So is there any possibility of x and y value? Okay, so let's say x is equal to 8, okay, and y is equal to 14. So this is the one possibility. So x is equal to 8, that is a 56, and y is equal to 14, that is again, that is 56. Correct? So this is the one possibility. Now second possibility is, that is x is equal to 12 and y is equal to 21. So suppose multiple choice question is there, and if suppose option is given like x is equal to 8, y is equal to 14, then that would be the correct option. If suppose if option is given x is equal to 12, y is equal to 21, then this will be the correct option. Okay, if suppose both option is there in the multiple choice, okay, so then both options are correct. This is the answer of this example number 2. Clear? Now the next question is yes. So next example, that is example number 3. So 2x base 5 is equal to 3y base 6. Okay. So in this, base is given, left hand side, right hand side also base is given, but we need to find the suitable value of x and y. Correct? So now again just you convert in the decimal part, this left hand side and right hand side also. So left hand side, if we convert this base 5 into decimal, so what we have to do? Simple, 5 to the power 0 and 5 to the power 1. This is the weight of the particular bit, and just you multiply the weight by the corresponding bit and just add all this. So 5 to the power 0 is 1 multiplied by x, plus, that is 5 to the power 1 is 5 multiplied by 2, that is 10, 10 plus my x is equal to, here same as 6 multiplied by 3, that is 18 plus y. Okay, now that is x minus my y is equal to 8. This is the equation. So now just you check here again. So x, because this is the base 5, because this is the base 5, So x can be 0, 1, 2, 3 and 4, correct? And y, because right hand side here base is 6, so y could be 0, 1, 2, 3, 4 and 5, correct? Total number here is 6, here total number in counting, that is 5. Clear? So is there any possibility of to satisfy this equation x minus y is equal to 8, and x could be anything 0 to 4, y that could be anything 0 to 5. Okay, so let's say x that is maximum number. Okay, so x that is maximum number is 4, and y that is minimum number is 0. So there is no chance to satisfy this equation x minus y is equal to 8. So that is not possible. So answer is not possible to find the correct value of x and y. Now is it okay? So now answer is that is not possible, because x and y, if we put any value of x and y here in this equation, we will never get the right hand side part, that is 8. Okay, so now the next example is example number 4, that is uh, x base 6 is equal to 32 base 9 multiplication 24 base 5. Okay, so here again we have given the base, okay, and find out the value of this x. Okay, so again just you do the same uh, that procedure. So right hand side again the base is 9 is given, base 5 is given. So first you better to convert into the decimal. Okay, so again 9 to the power 0 and 9 to the power 1, here again 5 to the power 0 and 5 to the power 1. Okay, here 9 to the power 0 and 9 to the power 1. So 9 to the power 0 is 1 multiplied by 2. 9 to the power, this is 27 plus 2, that is 29 is there. Okay, this is the base 10. And here that is 5 to the 10 plus 4. So that is 14, that is base 10 is there. Left hand side that is as it is x, that is base is 6. So now 29 multiplied by 14. Okay, so directly we can multiply. So because base 10 is given decimal, so now 406, that is base 10 is there. Okay, now what will be the x if suppose base 6 is given? So it's a conversion from decimal to any number system. Okay, so decimal to any number system. So in the previous lecture that we have done this type of conversion. So now the procedure is successive division. So 406, that is successively divide by 6. Okay, so that is 67, that is remainder is 4. Okay, again 6, 11, 6 just 66, remainder is 1, that is 6, 1 just 6, that is remainder is 5. Okay, so now answer is 1514, that is the our x, and base 6 is there, so this is the answer. Okay, so now next question is example number 5. So 267, that is base 8 is given, we need to find that is x, that is base in 11. Correct. So base 8 is given and we need to find the value of x in base 11. So first let us convert this base 8 into the base 10, and we know the procedure. Okay, and then later we will convert this base 10 to base 11. that also we know the procedure to convert this decimal to base 11 and any number system to base 10. Okay, so any number system to base 10, again the procedure is same, that is a to the power 0, a to the power 1 and a to the power 2. Okay, and just you multiply the corresponding bit. So a to the power 0 multiplied by 7, that is 7, plus a to the power 1, that is 8 multiplied by 6, that is 48. Okay, and a to the power 2, that is 64, that multiplied by 2, that is 128. Clear? So 128 plus 48 plus 7, that is equal to 183. So 183, that is base 10, and we need to convert this into the base 11. So that is very simple, successive division. So 183 base 11, sorry, so yes, base 11. So 11 1 ja 11, 7, 11 6 ja 66. So the remainder is 7. Now again 11 1 ja 11, now remainder is 5. Okay, so now answer is 157, that is base 11, that is the final answer. So x is 157. Clear? Okay, so now next question is example number 6. Let's say 41 we have given, root 41 is equal to 5. Clear? So we need to find the base. So in which base the root 41 is equal to 5? In which base root 41 is equal to 5? Okay. So first convert both side into the decimal. Again, first convert the both side into the decimal. So here left hand side, let's say base b is there. Let's say base b is there. Okay. Here also base b is there. Correct. So left hand side is 4b plus my 1 and right hand side that is a 5. Now is it okay? Okay, because that is conversion of this right hand side into the decimal, 5 to the, sorry, b to the power 0 multiplied by 5, that is 5. Okay, and here that is 4b plus 1, that is under the root. Clear? So now this is a, this left hand side that is decimal, right hand side that is also decimal. Now we can do one more thing. 4b plus 1 is equal to 25, that I can write. But here directly I cannot write 41, or that is 41 is equal to 25, that I cannot write. Why? Because this is only possible in the decimal. Okay, the square root of 5, the square of the 5 is equal to 25, that only happen in the decimal number system. Okay, but in the first case, in the first equation, we don't know the base. Okay, so we cannot write 41 is equal to 25. Clear? This is a row. Now is it okay? So first you do the left hand side in decimal equivalent, right hand side also decimal equivalent. Now in the second this line, second equation, now both side we have the decimal part. So now we can do this 4b plus 1 is equal to 25. Now rest part is very easy. 4b is equal to 24 and b is equal to 6. So base 6, in base 6, 41 root is equal to 5 only can happen. Okay, so that is answer is b is equal to 6. The important point is here only, this one. That's it. Now the next question is, so 23 plus 44 plus 14 plus 32 is equal to 223. Okay, so in which base this left hand side is equal to 223? Correct. So again the procedure is same again. Just you assume 23 base b. Okay, 44 base b, 14 base b plus 32 base b, and right hand side also, that is 22, sorry, 223, that is base b. So again same procedure, just you convert first into the decimal. So decimal, that is 2b plus 3. 4b plus 4, b plus 4, 3b plus 2 is equal to 2b square plus 2b, okay, plus 3. Clear? Now, after solving this equation, that is 10 plus 8b is equal to 2b square, okay, or b square minus 4b minus 5 is equal to 0, or this is a quadratic equation, so b is equal to 5, that is a valid value of the b where b is the base, so base that can never be equal to negative, or if suppose positive, another value is positive, then base that uh, cannot be less than 5, okay, because the number here is 4, okay, so the correct value of the base is 5. Now is it okay? Correct. So now the next question is example number 8. Question is, this one is very important question. The decimal equivalent, the minimal decimal equivalent of the number is 1 to C. Okay, is, so now you see the minimum decimal equivalent. Okay, so this 1 to C that is given. Okay, so here base is not there, base is not given, that is I don't know the base is 16 or base whatever, I don't know the base, the value. Okay, so 1 2 C, correct, it is not 12C, it is 1 2 and C, it is a 3 bit 1 2 and C, so we don't have any information of the base, but actually the question is we need to find the minimal decimal equivalent. Okay, so let's say preliminary of this question, let's say for example, uh, let's say that is 32. Okay, so 32 uh, base, let's say base 4 is given, so what is the decimal equivalent of this base 4? Okay, so decimal equivalent is 4 to the power 0 and 4 to the power 1. Okay, so that is 12 plus 2, that is 14, correct, so that is 14 is the decimal value, so 32, that this number system is also correct, that is base 5, that we can also write the base 5. Okay, so again convert this into the decimal part, so 5 multiplied by 3, that is 15 plus 2, that is 17. Okay, 32, that is base 6 is also the valid correct number system, so now convert into the decimal, so 18 plus 2, that is 20, correct, so now the minimal decimal value is this one, the minimal decimal value is, correct, this 14. So how do we know the minimal decimal value? Because just actually base is just greater than the maximum digit. So here the bit is 1 to C, and C is what? That is A is equivalent to 10, B is equivalent to 11, and C is equivalent to 12. So now base is 13. We need to consider the base is 13. Okay. So now you do the decimal part, 13 to the power 0, 13 to the power 1, and 13 to the power 2. Okay, we also can assume the base 14 also, base 15 also, base 16 also, but after assuming the base greater than 13, we cannot get the minimal decimal equivalent. Okay, so 13 to the power 0 multiplied by C, that is 12. 13 to the power 1 is 13 multiplied by 2, that is a 26, plus 13 to the power 2 is 169. So 169 plus 26 plus 12, that is answer is 207. This is answer. This is the minimal decimal equivalent. This is the minimal decimal equivalent. Okay. So next question is just one question is just a second. Yes. So example number 9. So the question is x and y are two successive digit is given, okay, and it hold xy is equal to 25, okay, and yx is equal to 31. Is base 10 is given. And assume y is greater than x, okay, then find the value of x and y, okay. So solution is y is greater than x and y are two successive digits. So first equation is y is equal to x plus 1. This is the equation number 1. Okay. So y is greater than x and y are two successive digits. So y is equal to x plus 1. Now another data that we have given, xy is equal to 25. So xy is equal to 25. Can we convert? Because we don't know the base, right hand side is base 10. So left hand side we don't know the base. Let's say base b is there. Okay. So can I write xb plus my y is equal to 25? Okay. Now another data we have given, that is yx is equal to 31. Again we don't know the base of left hand side part. So can I write this yb plus x is equal to 31? Let's say this is equation number 2. Let's say this is equation number 3. Okay. So this y value, so xb plus y value, can I write this x plus 1 is equal to 25? Okay. And x b plus 1, or let us this xb plus x as it is equal to 24. This is the equation number 4 is there. Okay. And here I am doing this next is xb, okay, xb plus x is equal to 24. Now from equation 3, y is x plus 1 into my b plus x is equal to 31. So xb plus b plus x is equal to 31. Okay, correct. Now xb plus x is equal to 24. xb plus x is equal to 24. So 24 plus b is equal to 31, and b is equal to, that is 7. So now base is, that is 7. And if base is 7, then x value is 3 and y value is 4. Clear? So x value is 3 and y value is, that is 4. So that is the answer. Clear? Now next question is, let's see, yes. So now example, I think 10 is here. Yes, 10 example. So this very important question. So the question is, let the decimal equivalent of binary number and binary number is A3, A2, A1, A0 base 2, because binary number is given, is represented as capital N. Okay, then obtain the decimal equivalent, of A3, A2, A1, A0, 101 base 2 in terms of N. Okay. Okay. Now see the solution. Okay. So first, uh, let us understand this concept. 1 is, that is 1 is binary. What is the decimal equivalent is, that is 3. Okay. So if we are appending the 0 at the LSB position, now the decimal equivalent is 6. Again, if we are appending the 0, one more 0 in the LSB side, now the decimal equivalent is 12. Okay. So now the concept is, if we are appending the 0 at the LSB position, the decimal equivalent is double the previous value. Clear? One more concept. Let's say 1 is equivalent to 3. Okay. 1 that is equivalent to, can I write this 6 plus 1? Because this is 7, so that is 6 plus 1, because this is a 6. Now 1 plus 1, that is 6 plus 1. Okay. So can I write in the sense 2 multiplied by 3 plus 1? Just double the previous value plus 1. If we are appending the 1 at the LSB position, if we are appending the 0 at the LSB position, just it is the double the previous value. And if we are appending the 1 at the LSB position, then double the previous value plus 1. Now I think the concept is easy. So just you do this like A3, A2, A1, A0, this is the N. Okay, this is the N. Now A3, A2, A1, A0, 0. Now this is the 2N. A3, A2, A1, A0, 1. Now this is 2N plus 1. Okay. Now we don't have the space. Okay. So let us do here the left side. So this A3, A2, A1, A0, 1, 0. Okay. Now it's a twice of the previous value, 2N plus 1. Okay. So that is 4N plus 2. That is 4N plus 2. Now again A3, A2, A1, A0, 1, 0, 1. Okay. So 101 is twice the previous value, 4n plus 2 plus 1. So now 8n plus 5. So this is the representation of A3, A2, A1, A0, 1, 0, 1. Now clear? Okay. So similarly, we can also do another question. So let's say this is example number 10, this is A part. So let's say example number 2, example number 10, so B part. Okay, so B part is uh, A3, A2, A1, A0. Let's say base 5 is given and it is represented by capital N. So what is the representation of A3, A2, A1, A0, 2, 3, 4, 0, base 5 in terms of the N? So now answer is, see, A3, A2, sorry, here A1 is there. A1, A0 and okay, so this is the N. Now A3, A2, this one is given. A3, A2, A1, A0, 0 is 5n because base 5 is there. This is the base 5. Okay. Now A3, A2, A1, A0, 2 is 5n plus 2. Now here A3, A2, A1, A0, 2, let's say 0. Then 5, sorry, uh, yeah, 5 multiplied by 5n plus 2. So that is 25n plus 10. Okay. In the previous question, just double the previous value. Here, the 5 times the previous value. Clear? So now, here, again A3, A2, A1, A0, 2, 3 is 25n plus 13 because plus 3 is there. Now A3, A2, A1, A0, 2, 3, 4 is 5 times 25n plus 13 plus 4. Now 125n plus 69. Clear? And at the last, let's see here, A3, A2, A1, A0, 2, 3, 4, 0. So that is 5 times 125n plus 69. So that is 6, 2, 5 n plus 3, 4, 5. So this is the final representation of this one. So the answer is 6, 2, 5 n plus 3, 4, 5. Okay. So that is if suppose let us do the generalization of this question. Yes. So now example 10 C part. So let's say A3, A2, A1, A0, X base B. So now the representation B, okay, because base B is given. Now let's say this is, let's suppose this is given, that is N. So that is N, okay, plus X is there. That is the final one. Okay. So this also we can compare the previous two A and B part. Clear? So this is the final A3, A2, A1, A0, whatever be the value of X, whatever be the value of B, whatever, so yes, X and B, whatever be the value of X and B, just you multiply like this one. x and b. Okay, and that is the representation that is given in the starting a3, a2, a1, a0 in base b. If suppose it is represented by n, then what would be the representation of a3, a2, a1, a0 multiplied by x, this x. Okay, base b, that is this one n. Now the answer is bn plus x. Now is it okay? Clear. So in the next class we will do the concept of complement. Okay, so thank you. Okay.